Hello everyone, welcome back to my YouTube channel. I'm Chandana, pursuing 5th semester in the Department of Electronics and Communication Engineering at Sri Venkateswara College of Engineering, Bangalore. Subject Digital Communication with the subject code BEC 503. And today I'm going to discuss about the topic Analyze Modulation Techniques in Digital TV Broadcasting. So these are the contents I'm going to discuss today. So, what is digital TV broadcasting? So, it is the transmission of television signals in a digital format. So, in analog TV, which uses continuous signal to transmit video and audio, and in the digital TV, it uses the binary data in the form of zeros and ones. And digital TV allows for improved quality, so in superior picture and sound quality, and efficient spectrum usage and additional features like interactive TV services, electronic program guides, and multimedia content. Transition from analog to digital broadcasting. So the shift from the analog to digital broadcasting began in the late 20th century. So since become a more standard in most of the countries. So there are some key reasons for transition, that is better signal quality and spectrum efficiency and enhanced services. Importance of modulation in digital broadcasting. So in modulation, where carrier signals varies in accordance with the message signals. So modulation is the process of converting digital data into a form suitable for transmission over air, cable or satellites. Its significance includes adaptation to transmission medium. So modulation prepares signals for specific medium, for example airwaves, cables, so that is used for broadcasting, and resistant to interference and spectrum efficiency. Now let us see the objectives. To explain the role of modulation in digital TV broadcasting, to introduce and compare key modulation techniques QAM, OFDM, VSB, and to highlight the advantages of these techniques in ensuring high quality, efficient digital TV services, to discuss challenges and emerging trends in digital broadcasting technology. So why modulation is required? So transmit signals over long distances. So this is the main reason why modulation is required. Efficient spectrum utilization and resilience to interference and noise. Key modulation techniques in digital TV broadcasting: quadrature amplitude modulation QAM, orthogonal frequency division multiplexing OFDM, vestigial sideband modulation VSB. So now let us see in detail about quadrature amplitude modulation. So it is used for cable TV systems and it combines amplitude and phase variation for high data rates, and it has features like high spectral efficiency and used in DVB-C digital video broadcasting cable, and 16 QAM, 64 QAM, 256 QAM. So these are the examples for quadrature amplitude modulation. Orthogonal frequency division multiplexing, that is OFDM. So it is used in terrestrial TV systems, for example DVB-T, and provides robustness against multipath interference. And how OFDM works. So it divides the signal into multiple subcarriers, and the subcarriers are orthogonal to avoid interference. So application in DVB-T or T2, so and in IPTV. Advantages: immune to intersymbol interference, that is ISI, supports high definition TV, that is HDTV. Vestigial sideband modulation, that is VSP, used in ATSC standard, that is Advanced Television System Committee. Efficient bandwidth usage for terrestrial transmission. Advantages: reduces bandwidth requirement and better performance in noisy environments. So now let us compare the modulation techniques. So in QAM, it is used for cable TVs, and in OFDM, so is it used in terrestrial TVs, and VSP used in terrestrial TVs. So robustness is moderate in QAM, and in the case of FDM, it is high, and VSB moderate. And bandwidth efficiency in QAM is high, and OFDM is also high, and VSB is moderate, and complexity in QAM it is high, and in OFDM it is very high, and in VSB the complexity is moderate. Types of digital modulation techniques, that is ASK, amplitude shift keying. Amplitude of carrier wave is varied based on digital input signal, that is 1 or 0, and operation includes a binary 1 is represented by high amplitude signal and binary 0 is represented by low or 0 amplitude signals. Advantages: simple to implement, low bandwidth requirements. Disadvantages: susceptible to noise as noise primarily affects amplitude, and application: low bandwidth systems such as optical fiber communication. Phase shift keying, that is PSK. The phase of the carrier wave is shifted according to the digital input signal. There are some types in PSK, that is BPSK and QPSK, where BPSK is binary phase shift keying. Two distinct phases, that for example 0 degree or 180 degree, represent binary 0 and 1, and QPSK, that is quadrature phase shift keying. So where four phases are there: 0 degree, 90 degree, 180 degree and 270 degree. So that are used to transmit 2 bits per symbol. And advantages: robust to noise compared to ASK and efficient bandwidth utilization. Disadvantages: more complex implementation than ASK and application Wi-Fi and satellite communication. Frequency shift keying, FSK. So frequency of the carrier wave is varied based on digital input signal, and operation includes a binary 1 is represented by high frequency carrier and binary 0 is represented by low frequency carrier. Advantages: so more immune to noise than ASK, simple demodulation. So demodulation is which brings back the original signal, and disadvantages: require more bandwidth than PSK. So application: radio frequency identification, that is RFID and modems. So differential phase shift keying, DPSK. So variation of PSK where the information is conveyed by the difference in phase between successive symbols rather than absolute phase. And the operation includes binary 1 is represented by phase shift and binary 0 is represented by no change in phase. Advantages: eliminates the need for coherent reference signal at the receiver, and the disadvantages: slightly lower noise immunity compared to coherent PSK, and applications Bluetooth wireless local area networks. So now let us compare the keying techniques. So the modulated parameter in ASK is amplitude, and in PSK it is phase, and in FSK it is frequency, and DPSK is phase or differential. And bandwidth efficiency in ASK is low, and in PSK it is high, and FSK bandwidth efficiency is medium, and DPSK it is high. So noise immunity, that is ASK it is low, and PSK it is high, and FSK it is medium, and DPSK it is medium. And complexity in ASK it is low, and PSK it is high, and FSK medium, and DPSK is medium. Advantages of digital modulation in broadcasting: improved video and audio quality, higher data rates and multiple channel supports, and robustness against signal degradation and interference. So challenges and the limitations of using digital TV broadcasting: complexity in implementation and need for advanced receivers and decoders, and spectrum allocation constraints. Impact on viewer experience. So the modulation techniques used directly affect the picture and the sound quality, and robust modulation can reduce the pixelation and improve overall viewing satisfaction, and broadcasting must continually access and adopt their modulation strategies for optimal performance. Future trends in digital TV broadcasting: adoption of higher order modulation, for example 1024 QAM. So previously used 16 QAM and 64 QAM and 256 QAM, and the integration with 5G networks for enhanced broadcasting, and advancements in compression techniques, for example HEPC. So conclusion part. So modulation plays a vital role in digital TV broadcasting. So by converting digital signals into formats suitable for transmissions, and the techniques like QAM and OFDM and VSPs are key in optimizing performance across different broadcasting environments. And ongoing innovations in modulation and broadcasting technologies will improve data rates and channel capacity and overall viewer experience. Thank you. Please do like, share and subscribe to my YouTube channel and stay tuned for more interesting videos like this. Thank you.